Okay, so in this week's lab, and actually for the next 2 weeks, we're going to play around with this climate change policy simulator. And there are two ways to use the program, and I wanted to walk through this and walk through a little bit about how this week's lab, or this next 2 weeks' labs, are going to be structured. So the tool is called C-ROADS, and where you're going to download it from is from this climateinteractive.org/tools/C-ROADS. Now there's two ways. So you go to this URL, you're going to see this screen pop up. But you can also click to download it, or you can run the tool online. So it kind of depends on how you want to do it. And so it runs on Windows and Mac, and it also we'll click and it'll download it. It'll download it as a .exe file on a Windows, a .dmg file on a Mac, or you can run it online. So when you click on run online, you'll get basically the same type of interface as what you're going to see when you download the program. Kind of depends on your browser. I've only tested this in Chrome, so if you have problems running it in your browser, like I haven't tested it on Safari, so because I don't have a Mac, so it might not work, and you might need to download it, but it's the same tool. Now, how this lab is going to be structured is we're going to be separated out into 6 countries. So you're going to, some of you are going to be assigned to US, some of you are the EU, and notice it tells you the names. Some of you are going to be the other developed countries. Got the names China, India, and all everybody else. So that's all the other developing countries. Okay. Now, how this program works is up here in the left, you've got your energy from your energy use and your CO2 emissions based upon that energy use. So when you look at the blue, right, that's the other developing countries, right? The expectation is that they're going to begin to skyrocket their CO2 emissions, between now and the year 2100. Whereas countries like the US and China, right, are going to kind of start to level off. All right. Whereas over here, we've got temperature increase, right? And right now we're on a bad pace. We're scheduled to go up to about 4 degrees Celsius increase, which is a significant increase. And it's got this big icon down here to make sure that it's clear that you can see that. Now, what you can do is you can go in to the application down here at the bottom, and you can change when you're going to change your reductions. Okay, so let's say that I want the US, I'm going to have us where our peak emission is going to be in year 2030, and I want to start reducing my emissions, let's say now, because emissions have reduced a lot right now due to the virus, and I want to reduce my rate at 35%, and I want to go all in on my forests, so no more forest cutting. And I'm going to plant forests like crazy. Okay, and you can do this for each of the countries. Okay, so then you can see what happens to the US, right? Their curve over time. Okay, all right, and then you can begin to see its comparison to other countries. So now you can begin to manipulate all of these other countries. Now you're going to learn that the US and EU, one of the challenges here is that we can't really promote much of the afforestation, because we're actually already done a pretty decent job on that as of other countries. But promoting forest development in countries like China and India might be more beneficial. Okay. Now, what you're going to see over here in the temperature increases is you've got this black line. That's basically if we do nothing at all, is where we're going to end up. And so the purple line is our current scenario. All right, so notice we made a little bit of a dent by the US beginning to get their reductions down 35%. So that's a pretty sharp drop that we got our reductions down, right? So if you're trying to present this as a case to your fellow students in the class, that might be a bit of a steep drop, right? But now maybe if I can do it for everybody, so we're going to be pretty ambitious. Oh, oops. Let's go with 2050 for everybody else over here. Alright, so notice it gave me a little error because I forgot I had to change my emission peak year. And we're all gonna, the rest of the world is gonna, whoops, 2000, haha, 200. There we go. Alright, so now I'm gonna target 35% for everybody else. I'm gonna reduce my emissions. Let's start in 2030 for everybody. 2030, 2030, 2030, and 2030. Okay. Now I can decide on my rate. So now I've got my peak year. This is when things are going to max out. And then I'm going to start reducing from there. And the year that I start reducing. Alright, so let's do 35% for everybody. Alright, see my curves? They drastically drop off. And look, over here I managed to keep my reductions to within 2.5 degrees. So this is a pretty aggressive rate. Okay. Now, what you can begin now is when you go into graphs, one of the things that you're going to have to wrestle with, and the world wrestles with this as a whole as well, is economics. So how is this going to impact our GDP? Okay. So when we begin to think about all the other developing countries in the GDP, you know, they're starting to head up. Look at China, right? Slow increase, right? This isn't a big increase for China, right? They're right now in a, was before the virus hit, a 10% per year roughly increase. And the US is also fairly slow. You know, I'm not sure the US will buy into that. Okay. You also can look at our net greenhouse emissions. Okay. So this kind of gives you a sense of, you know, the gigatons of CO2. You can go in and you can look at the GDP per capita. How does this impact? And you can look at this before you make any of these changes to after, because you're going to probably need to use something like that as an argument. And does this keep us below the 2.5 degrees? And the real question is, can you keep us below 2 degrees and have a deal that is something that is functional? Right? This is 2.3. I think most scientists would be pretty happy if we managed to do this. Right? So, but you can manipulate all of this. So there's a couple other graphs up here that you can manipulate. Right? And so you can look at the source of emissions, right, and see where the emissions are coming from. Okay. You can see them. Sometimes these graphs are a little easier to read sometimes, where you can see the total emissions, right, and then you can see the different colors of the nation stacked on top of each other. Right? So again, there's just different ways of viewing the different types of information. Okay? Now, you can also, under impacts, right, we've got some other options underneath it here. And remember, we didn't really talk about this much in class, but methane is the big is the big greenhouse gas, and that's lying under the tundra. If it begins to go up into the atmosphere, then we're in some trouble. But we also can look at sea level rise. Okay, business as usual, current plan. Right, so not a lot of impact on that. So if you're a country that has a lot of coastal cities, say particularly like a country like Bangladesh, this plan might not be a good one for you, and you might decide to argue against it. Okay. You can go under impacts, and let's go to nitrous oxide concentration, because the reason for that one, that's an issue for air pollution, because nitrous oxide is the key step in the production of ground level ozone, which is critical for asthma and for folks who have issues around breathing. And we look at current scenario, you know, makes a little bit of a dent, right? But then how does that impact our GDP? Did our GDP go up based on this? Did it go down? Did it change a lot? Is it enough of an impact? So these are some of the issues that you have to think about. So if you can, I recommend using the online version, just because it's fast, it's simple, and it should work in Chrome. So if you don't have Chrome, I would recommend downloading it. as it was originally designed for Chrome. So that kind of introduces us to the lab and the aspects of the lab. And now what I want to go through in the next little video is to go through how we want to structure this lab.